Okay, moving right along. Problem number 11 from the midterm 3 review sheet. And uh, consider the experiment where you roll two fair 6-sided die, and let the sample space of rolling the 2 die be called S2, and we're going to write S2 in terms of the sample space S1 of rolling 1 die, where S1 is just 1, 2, 3, 4, 5, 6. And so for part A, we want to write S2 is S1 crossed with S1. And these are all the ordered pairs where the first element and the second element are from S1. And so, for example, ordered pairs, something like 3, 4. Okay, so it's important to realize that when we build an experiment out of multiple smaller experiments, then the sample space of our experiment can generally be written as a cross product. Okay? Let E1 be the event that the sum of the 2 dice is an even number. Write out the elements of E1 and calculate the probability of this event occurring. E1 is the event that the sum is an even number. Let me start writing some elements out. I guess a 1, 1 works because the sum is 2. That's the only way we can make a sum of 2, right? Yeah, we can make a sum of 4, though, a couple different ways, with a 1, 3, a 2, 2, and a 3, 1, right? That gives me a sum of 4. How about a sum of 6? I can do a 1, 5, a 2, 4, a 3, 3, a 4, 2, and a 5, 1. That gives me a sum of 6. How about a sum of 8? I can do a 2 and a 6, and a 6 and a 2, right? That's it. No, I can do a 4 and a 4, or I can do, yeah, I got 3s and 5s. 5, 3, 4, 4. That gives me a sum of 8. Can I get a sum of 10? Yeah. 5, 5, 4, 6, and 6, 4. Can I get a sum of 12? Yes, but only one way, 6, 6. And I'm thinking that there are going to be 36 elements in S2, right? 6 times 6, which is 36. So I'm thinking maybe half of them would give even numbers. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, exactly half of them gave me an even number. So that kind of makes sense. So, write out the elements and calculate the probability. So the probability of E1, because they're equal probable, they're fair dice, is the size of E1 all over the size of S, which is 18, 36, or 1/2. Okay. I suppose then that the probability of getting an odd number is also 1/2 because it's just the complement of that. Part C says let E2 be the event that I get the sum less than 7. Less than 7. Less than, not less that 7. Write out the elements of E2 and calculate the probability. Well, let's see, I can go with a 1, 1, a 1, 2, a 1, 3, a 1, 4, a 1, 5, but I can't go 1, 6 because that's 7, and it's supposed to be strictly less than 7. And then I can go 2, 1, 2, 2, 2, 3, 2, 4. That gets me up to 6, so I can't go any higher with starting with a 2. Now starting with a 3, I can go 3, 1, 3, 2, 3, 3, and that gets me up to 6, so I can't go up to 3, 4, 4, 1, You see the pattern here, right? 4, 2. That gets me up to 6. 5, 1 is already 6. And sum of less than 7, I can't have any 6's at all. Right? Yeah. Okay, so I just have to stop there. And the probability of this event is the size of that event all over the sample space, which I guess I have to count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 of them all over 36, which is 5/12 if I divide by 3. Okay, that's part C. Now, parts D and E consider the union and the intersection of these two events. And I think I'm moving on to the back of the previous page here again, like I had to do last time. And so, let's see. Let's consider the union first. Part D says let's consider E1 union E2. And, so it's all 18 of these guys plus any of these guys. Really, I want you to write out the elements of that and calculate probability. Okay. 1, 1, 1, 3, 2, 2, 3, 1, 1, 5, 2, 4, 3. I'm just copying them down here. 4, 2, 5, 1, 2, 6, 6, 2, 3, 5, 5, 3. I didn't mean to make you do this much work. I guess it's not that bad. I'm surviving. 4, 4, 5, 5, 4, 6, 6, 4, and 6, 6. And now I need to union it with these guys. And so I have to ask myself one at a time which of these guys goes in. 1, 1's already here because it's an even number. 1 and 2 is new. 1 and 3 is even. 1 and 4 is new because it's odd. 1 and 5 is even. 2 and 1 is odd, so I have to add it. 2 and 2 is even. 2 and 3 is odd. Looks like half the numbers over here in E2 are also in E1. 2, 3, 2, 4 is even, so it's already over here somewhere. 2, 4, there it is. 3, 1 is even, so it's already here. 3, 2 is new because it's odd. 3, 3 is even, so it's already here. 4, 1 is new because it's odd. 4, 2 is even. 5, 1 is also even. So here's the set. And the probability of E1 union E2 is then, I'll just count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 16, 17, 18, 19, 20. 1, 2, 3, 4, 24. Well, it's the size of that set all over the sample space, which is 24/36, which is 4/6 or 2/3. Okay. Part D says, does the disjoint event formula apply to this probability? If so, show that the formula works. If not, show that it does not work. Well, it does not apply here because these two sets are not disjoint. E1 union E2 is not equal to the empty set. I'm not going to bother to write them all out right now. But it's not equal to the empty set. And so the formula does not apply. And if I calculate the probability of E1 plus the probability of E2, we'll find that it does not equal the probability of the union. And E1 and E2 have probabilities of 1/2 and 5/12. Which is 6/12 and 5/12, which is 11/12, which is not equal to 2/3. Okay, again, just like in the example, last example, the sum of the probabilities is way too big because of overcounting, because of double counting the elements in the union, in the intersection. Finally, consider the event E1 intersection E2. Write out the elements and calculate its probability. Well, it's all those in E2 that are also in E1. So it's those in E2 which have an even sum. 1, 1, 1, 3, 1, 5, 2, 2, 2, 4. I'm looking up here at all those that have an even sum. 3, 1, 1, 3. They already did 1, 3. 3, 1, 3, 3. I'm just going along this list here, looking for those with an even sum. 4, 2, and 5, 1. Okay, so these are all the elements from E2 that have an even sum, which means we have two odds added together or two evens. 1, 3, 1, 5, 2, 2, 2, 4, 3, 1, 3, 3, 4, 2, and 5, 1. Yeah, okay. And so the probability of this event is the size of that event, all over the size of the total sample space. Oops, sorry. So the probability of this intersection, well, I may have been off the page that whole time here. Here I wrote out the intersection, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 elements in there. 9 out of 36 is 3/12, or 1/4, or 0.25. Okay, so that should finish problem 11. Sorry if I went off the bottom of the page there.